really, oh, thank you. We realized that we just had so much in common with the processes that we were undertaking and the way we were approaching it that we just decided to sort of formalize this and make it into a conversation that we could have in a more public way. And so we would very much appreciate your feedback and participation as we go through. Feel free to interrupt. We do have material here to present, but also would love to hear your perspectives and ideas and experiences as well. So welcome to our discussion. We are very happy to have you here today. Again, I'm Leah, lead faculty over the sciences. I love to fish and I love to teach. Anyone except for my children, they are 7 and 10, going on 17 and 20. So yes, anybody but them. So yeah, Tonya, over to you.
Hello, my name is Tonya Haas, and I teach math, as Leah had already mentioned. I like to read, and I think it's important to point out that that would not be coffee in the mug for me. That would be tea. I am not a coffee drinker.
Well, I have my coffee ready to go for sure.
I have my tea, so we're good. We're ready to go.
All right. Well, we just want to start by, of course, thanking you for being here. We are excited to share our experiences with math and science and our course revisions, our course development, curriculum development with you. And it is such a hard process to kind of tease apart and figure out where do we start because it is such an undertaking, as we were talking about earlier. And so we decided to just kind of break it up into why we did what we did, who was involved, which is really the center point of all of this that we're trying to talk with you about today, is the value of our faculty, our adjunct cohort, just amazing group of people with amazing perspectives, again, and that's really who we attribute the success of this process to. And then we'll talk a little bit about how we went about it. And again, here we would love to hear your experiences, the differences maybe, ways that we could do things better. All of that is definitely up for grabs in our discussion today. And then we'll kind of sum up with some outcomes and perspectives on some of the successes that we've had at the course level for our students, faculty, and also for our college as well.
We'll start with the why. And I'm sure if we asked you why change their curriculum, everybody would have really good answers. When you get the opportunity, take advantage of it. If a course isn't performing well, see where you can revise it to improve it. We're going to look at two things that are very important at CTU. We are very mission driven, and our main goal is always student success. We're always looking to see how we can improve our student experience. So there's our mission statement. I'm not going to read it to you, but some keywords: diverse, innovative, experienced faculty, professional goals. So talking about our experienced faculty, why not use them? Not just to teach the class, but to get their perspective. So we have that diverse perspectives of our experienced faculty of what should be brought into a class, what's important in a class. So use it to help our diverse student population be as successful as they can to progress through their academic journey. Also, incorporating those real life applications. The more people we talk to, the more, I guess, the bigger variety of real life applications we can bring into a course. So that's the focus of us right now for the two revisions we're going to talk to you about. And you'll see as we go through, we're going to talk about two classes, a math class and a science class.
Awesome. Yes. And as far as who is involved in changing the curriculum, as Tonya was saying, our faculty, what a wealth of knowledge they are, what a wealth of experience. Um, they have wonderful ideas, a lot of industry relevance, and also exceptional amounts of instructional experience and expertise. So they know what our students are going through. They've in the sciences, our average tenure for our adjuncts is over 6 years. And that's counting new people, so it's pretty amazing how long our faculty have been a part of our mission and have been instructing students. So we really wanted to tap into that wealth of knowledge to help make our curriculum the best it can be for our students to bring them the most relevant information possible. Okay, and this is a kind of a funny picture. This was one of our holiday cheer and volunteer events here for the science group. We have a group of almost 40 adjuncts. We teach there, it's kind of like a brick and mortar institution. We have the lecture class, And then we also have the lab class that goes along with it. So it's sort of a pair. Definitely an opportunity there to update both classes and to align them together, as well as updating both of them to the more relevant, industry relevant information. So a couple of different nuances when it comes to the sciences. We did have lead SME as a part of this course revision process, as well as 5 content SMEs. So, but we'll talk about it in a little bit. Lots of input from everyone who was able and wanting to be a part of that.
For our math revision, the course that we're going to discuss today is a higher level math course. So we do have a smaller pool of faculty that teach that class. We have 6 adjunct faculty who teach the course. All 6 were invited to participate in the revision. 4 opted to participate. So same process as Leah's. We had a lead SME, and then we had 4 content SMEs that we'll talk more in detail about. So now let's move on to the how. So step 1, faculty-centered revision process. So we've already mentioned a couple times, our goal was to have as many eyes on this revision process from the beginning as we could. So we reached out to our faculty because we wanted feedback from our faculty. We wanted feedback from our students. The feedback from our students came in a different way. We used end of course surveys, but we really wanted the feedback focused course design. How can we make this the most effective course we can? We also wanted checkpoints. Before we even began to revise the course, we had checkpoints for what's the course going to look like and make sure it's ordered properly. And then, as we've already mentioned, wanted to utilize different perspectives because our goal is always that ideal student experience or the best student experience we can. And having different perspectives allowed us to identify and develop different themes across the curriculum. So I'm going to start with the math process. And as Leah mentioned earlier, we were talking one day and we were comparing notes on our revision. And it was interesting that they were very similar processes. And that's what led to this presentation. So how we started the math presentation is there were 2 ways to participate, through email or through meetings. So at the beginning, when we decided we were going to revise this course, I reached out to the 6 faculty who teach it, and I asked for just general feedback about the course. What works well? Where do we need to improve? Is there content that we're missing? Is there content that's outdated? Do we need more real life examples? I just wanted everything they could tell us about the course to prepare for the revision. I also went through the recent end of course surveys from students to see what students were saying about the course. I took all of that feedback and created a revision plan. Here's what I think the course should look like. Send it back out and also scheduled a meeting with the faculty to say, hey, let's sit down and now look at everybody's ideas all together. And I received yet more feedback. From that feedback, I had the course structure. At this point, we knew what topics we wanted to include, what the theme was going to look like. We had general ideas, but now I wanted everyone to look at it very specifically at the ordering. Does the ordering of this material make sense? Will it be an easy navigation for our students to progress through this course? Do we see any obstacles that we need to prepare for? So basically, let's dot the I's, cross the T's. So everybody looked at it. I met with 3 of the faculty and we went through it every line, one line at a time, to really make sure that we felt this was going to be a successful course. And that's how we developed our revision plan or the course structure.
Similarly with the 101, 103 group, lots of opportunities for feedback from my group. In fact, I had been the lead over the 200 level group, which was a little bit of a higher level environmental science courses, and we went through a course revision a few years ago. And when I came on board at the 100 level with our introductory science courses, and it's sort of a survey course, you know, a little bit of everything. But like Tonya's saying, the ordering is really important, which we'll get to a little bit later. But I was hopeful that we would be on the schedule soon to undergo a course revision because it had been a little while. And so I really started talking to the faculty early on. I found that it really instilled a lot of positive feedback, some just motivation with our faculty. I value their experience, and I think that that comes across when you ask them, what do you think? So we started that conversation in April of 2023 with our focus groups. We started having, meetings as in small groups to try to figure out where we wanted to go with this. Lots of great ideas, some innovative ideas as well from our science group. We had a Teams group that we set up so that we could all look at the same material. Proved to be a little bit clunky with our file exchange and that type of thing, but it was a place where we could all meet and update in our own time. We also had more meetings. We had votes. So there were a couple of major ideas that were presented that were fantastic, and we took a vote and went with a vote. Um, Again, lots of feedback opportunities with individual meetings. We selected our subject matter experts, had individual meetings with them as well to make sure we were on the same page, that we had, like Tonya was saying, had developed an outline. We're in agreement, excited about moving forward, and we all knew the direction we were going to take. Because although it sort of is siloed with our different units, we have 5 different units of material. They needed to know what each other were going to talk about to make the most effective use of their time, because science, a lot of it is overlapping. And so how much do I need to review really depends on how much was covered in the other units. So it did take a lot of integration with our subject matter experts. And then a little bit less than a year later, we had our kickoff call, and here we are now in our full launch mode. I think we're in our 5th session now of the completed curriculum updates, but it was definitely a culmination of a lot of conversations over the last 2 years, basically. All right. Next, again, for the how is we appointed a lead subject matter expert, or lead SME. And then the goal of the lead SME really is to create an outline that ensures that there is proper flow, proper progression, that there isn't too much overlap, but there's just enough review to make it effective for the student experience. There's also a revision workflow with checkpoints and review for refinement of that material to make sure that it was effective, made the best use of our structure in terms of how we set up our courses. We do use IntelliPath, which is a kind of a unique situation in terms of it being sort of like a textbook and a quiz all in the same package, which is really convenient. And that's the main area where our subject matter experts were putting their efforts, was into the content in the IntelliPath material, and also creating those questions as well.
For our math revision, I was the lead SME, and I'll talk about my responsibility in a minute. But as I mentioned earlier, I had 4 content SMEs, and our adaptive learning system, as Leah mentioned, in Telepath, their goal for the content, or I guess their responsibility, the content SMEs, were to either write a complete new lesson or take a lesson that was in existence and revise it. So that was their primary responsibility at the beginning: write it or revise one. Then they had to write questions for a new lesson or revise the questions, review all the questions, see if they would still work in the lesson or revise them. Then they had to scaffold the questions into 3 different groups. And I'll get into this a little bit more later, but this was a really important change to our math course, was leveling the questions into 3 different levels. Also, from our end of course surveys from students, they're always asking for more practice. Not graded questions, but practice before they get to the graded assignment. So another goal was to add interactive examples into every single lesson or into the learning material for each topic. And then to make sure that the real life scenarios were something that would interest students, and a variety of them. So we didn't want to just focus, this is a business math course, but we didn't want to just focus on one type of business. We wanted to make sure there was healthcare, there was management, sports, any type of real life scenario that we could add in to keep the interest of a diverse student population. My responsibility was to take each of those lessons, review them, make sure that nothing was missed, make sure that they were seamless from one lesson to the next for each of the individual topics, and then either approve it or return it to this contents me for additional information. And then my other responsibility was to create videos for each unit and lesson. So, as Leah mentioned earlier, we have 5 units. In each of our courses now, we have an introduction to the unit video. And then our students also wanted more videos, different learning styles. Some students can read and be okay with that, others want to see and hear it. So, we created videos for every single lesson within the course. So, that was one of my responsibilities.
Tonya, I have a question for you. When it comes
Yeah.
to your scaffolded questions, do you think that, so you're teaching a higher level math, you're revising a higher level math course, are those scaffolded questions scaffolded in terms of what you would expect an introductory level, mid-level, higher level type of approach? Or do you think that scaffolded questions would work at the introductory level only, or is it because it's a higher level math course that the scaffolded questions are?
So I will explain the way we scaffolded them later in more detail, but we actually have them in all of our revised math courses from our 100 level to our this highest level math course. Basically, it follows Bloom's lately. Let me just say, Bloom's in mathematics can kind of be difficult because apply is a higher level Bloom's, but we apply and solve in a 100 level math class. So basically, the questions are level one would be truly understanding definitions, which formula is correct. The second would be, do students know how to correctly set up the formula? And then third would be applying. Can you pick the correct formula? Can you insert the values or substitute the values in properly and then apply them by
Okay.
solving?
Excellent. So more context
Great
oriented.
question.
Okay. Well, it's not hard to see how this talk came about is because Tonya and I just go back and forth. Wait, can you tell me more about this? So that's why we're here today. Learn more. Okay. When it comes to our science courses, like I said, we do have our introductory lecture class. It's not really a lecture, but that's the main full credit course, and also the accompanying lab class. All of our students at CTU are required to have the science credits, whether they transfer in with them. That happens sometimes. Maybe it's one or the other, the lecture or the lab, but usually they'll end up taking both of these classes with us. So we have students from all over who have very diverse goals when it comes to their academic and professional lives. So we wanted to align our courses, our introductory science courses, but also have it apply to criminal justice majors, to nursing majors, to cybersecurity folks. I can't even, business majors, all of these different uses that science could be applicable for. When we know that, as scientists, we believe that science is in everything and that scientific thinking is very valuable no matter what your academic and professional goals are. But that's something we wanted to really accentuate: career connectedness with our students, scientific methods, scientific thinking, how to test hypotheses, and that type of thing. One of the really great ideas that our content SMEs had moving into this process was, so chemistry. You probably just got chills just saying the word chemistry. Almost nobody likes it. So it was just a really big stumbling block for our students. And we had previously had an entire unit of chemistry all in one week, and it was a lot, and it was not the best experience for our students in that way. So one of the really innovative ideas was to kind of break the chemistry down into different applications. So how does chemistry apply in earth science when we're talking about rocks and minerals? Of course, chemistry is super important there. When we talk about biology, DNA, RNA, all of these macromolecules, they're all linked together through chemistry. So what is the chemistry that applies there? What about in physics? All of these different applications of chemistry we were able to incorporate, and in that broader context. So instead of having it to be for lack of a better word, saturating the students with chemistry in that 1 week, we were able to integrate it into the different disciplines to make it more approachable and interesting and digestible to the students. So that was one of our great ideas from our content SMEs, as well as making sure that in our main class and also in the lab that we were able to take advantage of the lab by making it a more interactive experience, by diving a little bit deeper into some of these materials and these ideas and concepts. So it was a really nice experience for our faculty to get involved, to really get into the details of what happens with these various scientific topics. Let me see, did I miss anything in the chat? Oh, Josh, you love chemistry? That's awesome. It hasn't changed any in the last 30 years. That's one thing about chemistry, is that once you've learned it, it's the same. How we used a lead SME, worked on revisions. The hierarchy, well, in this case, both Tonya and I volunteered to be the lead SME. It is a separate role from, sorry, go ahead.
We both do oversee these classes, so it does make sense too that we were the lead SME. Sorry, Leah, I didn't mean to interrupt you.
No, thank you. And I just saw that you replied in the chat. Thank you. Yes, we do oversee these classes, which makes it a little bit more understandable why we would volunteer for that. But it was also a very separate role. So for our group, although I was the lead SME, when it came to our course development process, once we entered into that phase, my work was done basically with the content SMEs. They solely communicated with our instructional design team at that point. To be fair, we had already had discussions for a year plus on that, so we had really ironed out a lot of the works. In Tonya's case, which she'll get to in a little bit, it was a little more fluid and, I think potentially a little more oversight for her, which was really effective. And if I had it to do over again, I might advocate for that as well. But either way, well-prepared SMEs really saved a lot of time. And the more effective, the more clear all of the direction was up front, the better the process went.
The lead SME position for at least the math revisions kind of was developed because of what you were saying. When we were too far along in the process and we were finding out, wait, we don't have this transition, or wait, this topic was dropped because one SME assumed another SME was doing it. So really, we developed this lead SME process to make sure that we weren't having any gaps. There weren't any holes in the data. So that became the primary responsibility of the SME. And it has helped significantly, I know, in both of our courses, especially the math revisions. We just keep evolving with every revision we have.
Yeah, I think it's a really great idea to have that oversight toward the final product there. That way you know what the students are getting ready to come into contact with.
Yeah, if you can figure out how to translate that into your space, I really do think it helps a lot with revisions. And I think it makes the job of the designer easier because there's less that you have to find in the back of the revision process. So
yeah, I didn't know that this was kind of a unique setup. So again, this is why Tonya and I wanted to bring this into a more public setting, was because this is what I know, at least from my perspective, this is what I know from CTU, but I don't know how it's done elsewhere. And so we would love to know, although we're improving amongst ourselves, we would also love to know how other people approach these projects. So again, we can always improve. So, all right. There we go.
okay, continuing with our house, step 3, what was our main goal? What did we want to see happen as a result of these courses? So we've mentioned a couple times there was intent in how we ordered the content, and that was based on the feedback from our faculty, based on student feedback that we've seen in the end of course surveys. Our goal is to build the confidence in our students so they will continue on through the course. We wanted to create a consistent learning experience. And Leah mentioned there's the 100 and 200 level science. We wanted consistency there. In the math, there's 4 classes that our business students take. We wanted consistency. We didn't want them to get used to one concept or these interactives in one class and then go to the next class and say, hey, well, where are these? I thought this was helpful. So we really wanted to have a consistent learning experience for our students. And that way it helps students be prepared for their next steps. So, what did we add in our math classes? We have a lot of new ideas, and all of our math courses that our business students take are either revised at this point or in the revision process. And then we're going to move on to some other math courses next. But for our business students, what they're going to see in every math class they take are these interactive practices. And I take zero credit for these. This is our amazing instructional design team. They do great things. This is an example of flashcards, that interactive practice our students had asked for. They're asked a question, and they have the flashcard. They can figure out the answer, then click on the flashcard to flip it over to see the answer and an explanation. We have matching exercises. We have drag and drop exercises. Our instructional design team has done a fabulous job with those. We have also introduced the key terms at the beginning of every lesson. So, this is a network model lesson, if you're wondering. So, arcs, net flow, nodes are all new ideas, possibly to these students. So, the new terms are being introduced at the very beginning. That way, we hope the students will take notes of them. And then as they read them throughout the learning material, they'll know what those are and they'll learn more about it as they go on. One thing I don't have, we have more on the next slide, is this is really important to a math class, is for every single question in our graded assignment, students are given a hint if they want it, the option for a hint. And if they miss the question or if they get the question right, they have the option of reviewing the solution. And it's a really basic concept, but it's made such a difference in our math courses because students can actually look at the solution and we have step-by-step solution, all the steps included. So a student doesn't just miss it and say, oh, the answer's 30. Well, that's meaningless to a student. The answer's 30. If they understood that, they would have gotten the answer of 30. So we really wanted to provide that detail. And again, we hope that students are writing that down. And as they write it down, they're really learning and able to see where their error may have been. So the hints and solutions are very helpful.
That's a great idea because it's really the process that matters when you're trying to approach a math problem, not the answer. I mean, obviously the answer is secondary and hopefully right,
Right.
but yeah, it's hard to get the right answer with the wrong process.
Exactly. The other thing, I'm going to talk about the video first. The other thing is we have 2 different types of videos, a unit video, and this is an example of our unit video. It's basically, here's what you're going to do in this unit. These are the topics you're going to cover, and these are the assignments that you have. And we have one in all 5 of the units. They all look very similar, so students can see them and prepare for their week. And then within the learning material, which I don't have an image of, we have videos that we have created internally at CTU. And the reason the focus was to create them internally is because one thing we've found from our students is math is can be explained in different terms. So for example, integers and signed numbers, same idea. And if you understand math, you understand, oh, signed number is simply an integer. But for our students who are a little anxious or haven't had math for a while, that can make such a difference. So we wanted to focus on having videos that we make. So the same terminology is used in the learning material and the videos. So students can make that connection. If we send them somewhere else and this lesson's talking all about integers and they're talking about signed numbers, they might not make that connection. So that's one of the reasons it was really important to add these videos in. Now we'll go back to those leveled questions. In our math classes, when our students have a graded assignment, they have questions that they're pulled randomly and asked. The level of difficulty varies within those questions. And the way it was designed before, students could have the very first question could be the most difficult one that out of the number they were going to be asked. And then they could be asked a very easy one. Well, even if you're a math person, that's stressful. If your very first question is a tough question, it can do a lot to your confidence. So we wanted to build up their level of questions, build up their confidence, and help them step through the questions. So now, the first two or three questions that they're asked are what we consider level one questions. And as I mentioned earlier, it's making sure they understand the definition. What's an arc? What are the key points? Or what are the characteristics? Questions like that, just really understanding the definition of different terms. Level two, if there's a lot of equations, is understanding the different equations, which one is used for which scenario, what do all of the variables in the equation represent, things like that, setting up the equation. And then finally, once they've built up that confidence, they've built up that knowledge, now they're asked to do the actual calculating, formulating, solving, applying any term that fits the scenario in those level three questions. And by then, they're more confident in their answers. And we'll talk about in a few minutes the outcome. We've seen the results for our students. And I will say this is one of the things that our students have noticed and our faculty have noticed, but I'll dig into that deeper in a few minutes.
I think it's a really wise approach. And again, that comes from experience. It comes from understanding what the students are going through and trying to optimize the experience for them. So love that. I love that approach for math. I wish they'd had that when I was going through school. When it comes to our science courses, again, the integrating chemistry idea was, I think, really important, probably critical to the success that we've had with the launch of this new content because it's very rigorous. We are just taking on a lot of complex scientific topics, scenarios. We're diving into genetics, and even how genetics is being used to help cure disease in some cases. So to understand that, you also have to understand what happens first, so it's a very multi-step complex topic for our introductory students, but it's so relevant to their daily lives. It's so relevant to diseases that are fairly common and advances in medicine. So we want our students to know that information, but they have to understand the background of it first. But in any case, so real life examples is another focus for our science revision. In addition to scientists around us, there's even a lesson here called Scientists Around Us. So who are scientists? How do they use science? It's not just, doctors and surgeons, they're everywhere. There are lab techs. They're the people who are the clinical aspect of all of this. There are wildlife biologists. They're the people who are testing our water. All of these types of applications of science. There's also real life examples and uses. So for a business student or even an athlete, may have heard of that sports drink where it was formulated and in combination with some health experts, and that drink helped to better hydrate their players. It was sold, and of course, huge business from that just spiraled. So it's really interesting to see how science plays a role in throughout life in a lot of different ways. And so we really wanted to create a curriculum that resonated with students, that they would remember, that they would see the value of science in these different contexts. Another thing that we wanted to do, and here is again a nod to our instructional designers. I love the way they really bring the content to life, right? We write it, but when I write it, it's still in 2D and it still isn't quite, as cool as it could be. But when our instructional designers jump in and they're able to really bring it into a format that the students enjoy, that they're, like Tonya was saying, it's engaging. They have to get in there and click around. And it really puts a new life to it and puts another dimension to our content. So yes, we have careers in biology. We have some excerpts there from folks who are actually doing science in their real life. But we're also, one of our goals at the 100 level is to prepare our students um, for the next step in their 200 level environmental science courses. And so toward the end of our session and toward the end of our course, we incorporate electricity, energy, starting to get that discussion of where do we get our energy, renewables versus non-renewables. How does our use of energy impact the environment and vice versa, so anyway, it's a multiple, there are multiple things we're trying to do while we're optimizing our curriculum at this level, engaging students, reducing the barriers, and that really difficult chemistry unit, breaking that down and making that more interesting and more relevant, bringing in careers, preparing students for their next academic step into the environmental sciences, all of these things to help bring our students the best experience that they can have. Okay, so now that we have our content completed, so this is the point at which our content is complete. Now, what do we do with it? How are we going to bring this to the students? The kind of scenarios here with Tonya and myself are very similar in that we tried to bring them about intentionally and effectively. So it's all about change management. It's all about how to get faculty on board, even though they were involved in the process, getting them on board and excited for and prepared for this next step of launching it to the students. So we both ran some pilot sections, which we'll get into the details in just a moment. So smaller sections to represent hopefully the experience in full so that we could make sure everything was ready to go, and refine that course content, and also gathering the data on it to make sure that we were going in the right direction, that to see if there were any gaps that students needed filled, end of course survey data. Where do students need help? Where can we support them instructionally now that we've improved and updated the curriculum? What else in their student experience can we focus on to help make this the best possible course for our students?
To answer the question in the chat, I don't know what courseware our team uses. As far as our LMS, it's a proprietary LMS system. So how did we implement the changes in our math courses? As Leah mentioned, we ran 2 pilot sessions. As I mentioned earlier in the presentation, this is a small course. We only run 4 or 5 sections every session. So we started with 2 pilot sessions. We ran 2 sections and then 3 sections. Prior to the pilot sessions, we'll pick up the pace a little bit. I met with the faculty who would be teaching the pilot classes. I went over all the changes with them, provided them with any materials they may need. They could revise them and make them their own, but went over all the changes to the course. We increased in the second pilot to 1 more session, and then I checked the data weekly between the pilot sections and the non-pilot sections to see how the performance was. Was it performing well? Did we have areas we needed to work on? And some of the data, which we'll go over later, was assignment completion rates and student engagement. And then, of course, we tracked any issues that were found within the pilot course so we could fix it prior to the full launch.
Similarly, for the sciences, we ran pilot sessions. So we have upwards of 35 classes that we launch every single session, every single 5-week term. And so for the first 2 rounds, we did 3 sections. So just 3 classes were the pilot, and we were able to iron out a lot of those wrinkles. Then the third pilot was a 10-course pilot, so that was a little less than a third of our classes. And we had special meetings I called them piloteers, special meetings with them, with our instructors who were teaching those classes to see where we could help with the gaps. I gave them content. I gave them, not content, I gave them the materials that they would need to help with the students so that they didn't have to make all of that themselves, because we all know as being instructors, that's the difficult part, right? Is how do you make all the material that you need to teach this class? So, to help refine that and to make that the best it could be for our faculty. Again, collected data and tried to make sure that the courses would run as smoothly as possible when we did go that full launch and start teaching our 1,200 plus students, that next session. So
What did we hope for the outcomes? We hope to see benefits for our students. We wanted to see them improve or gain confidence, improve their competence as they went through the course. That's why we had that intentional content ordering. We wanted to see our student engagement at least stay the same, if not improve. And we wanted them to have a positive and consistent learning experience. And we reached that goal. Just to give you a little summary for math, here's some data. This is comparing our pilot sections to our non-pilot sections. And as you can see, they're all positive, which means our pilot sections outperformed our non-pilot sections. As far as student engagement, we saw an increased student engagement. Students were staying engaged further along into the course. We have a key week where we tend to see students falling behind a little bit. The first time we ran this pilot, it was just a little bit, a 1% increase. The second time, a 7% increase. Our assignment completion rate, not just submitting the assignment and working on part of it, but completing the entire assignment, increased to 15 and 13%. And then that we have two key weeks. One key week was when there was significant changes made to the course, and the other is that time where we tend to see students falling behind. And as you can see, we really saw a boost in the completion rates in those 2 weeks, which is really exciting for the course.
and that's awesome. So I don't have quite as compelling statistical data as Tonya, but I do have a lot of great student feedback. So for example, I talked earlier about how we're using some of this content to address um, disease treatment and that type of thing. So how CRISPR is being used. So this particular student had a brother who had passed, and he had Duchenne muscular dystrophy. And that is one of those diseases that CRISPR is being used and genetic treatment is being used for, at least preliminarily. And so it gave the student hope. He needed that day. It was just a really compelling message that I got from our student there, who really resonated with that new updated content that was relevant to him. I love these when a student says that the science has previously been my least favorite subject, but then it's honestly been my favorite so far. So I love that, that we can change the students' minds about science, because we've all had some teachers here and there that haven't been our favorite, and experiences and subjects that haven't been our favorite. So it's really, really great when we can provide those students such a great experience that it's changed their minds. And then another student who just out of curiosity did more than they needed to do for the assignment, just because they wanted to know. So all of that is great indicators from my lead faculty hat, that our students are learning, they're enjoying what they're learning, and that we're providing a great experience for them. When it comes to our outcomes for our benefits for our faculty, professional development. So our faculty are able to get, through being involved in the revision process, they're able to develop professionally. Some of our instructors are also pursuing their degrees in instructional design as well. And so that was really helpful to them to see the other side of that. And satisfaction. So student or faculty are involved in our students' experiences, and being involved in that process has really made them invested in our students, and made them satisfied with their work. It's also strengthened the confidence and leadership skills of our team. So I rely on them heavily for feedback. It's been a much more communicative group, a much more leveled group. We're all in this together, very teamwork approach, which has been really, really helpful as well.
I was able to meet with my faculty who taught the pilot, and they had so many positive things to say. And the overall theme was that they were spending less time helping students with questions and helping students with the technology. that they were actually helping students take everything a step further. Instead of focusing their outreach on engagement, it was more motivational and more conversation about, oh, how can we use this in other ways? They were able to, they were spending less time on doing the work and analyze, then more time on analyzing the solutions. So it was a lot of positive comments in the way they could able to change their focus from struggling students to really just motivating students to do more with the material.
And I totally jumped the gun and said all this before, but it made our team much stronger. And our slogan is so cringy, but it's teamwork makes the dream work. And it really has in this case. When it comes to our benefits for university, again, reinforces our mission, industry relevant. We included diverse perspectives and appreciate those diverse perspectives, and also incorporated career connectedness, higher quality of classes, better alignment of our curriculum with evolving community and industry needs as well. So really providing that industry relevant education for our students.
We are right at time, but if we have any time, if anybody had any questions, we also want to thank you guys so much for taking time out of your day today to attend. So if there's any other questions we can answer for you, we would love to hear them, or any feedback that you have, we would love to hear it. Thank you so much.
Thanks, Josh.